Yeah. Today we are going to explain what is inclined plane. Let us consider a body sliding down an inclined plane. First of all, we plot our incline. It has an angle of inclination above horizontal. This axis is the ground level. This is ground and this is our incline. This is an angle theta of inclination. And the body is placed here. Consider a body placed here. And then the body is moving down. This is an acceleration which is downward, means direction of motion. So we need to plot x-axis and y-axis. X-axis is an axis parallel to inclined plane. Because the body is moving down, this is the positive x and this is negative x. We know that y-axis is always perpendicular to x-axis. So we need to plot an axis which is perpendicular to x-axis. This is positive y and this is negative y. Now we are going to position the force of gravity. Force of gravity is a force which is always vertically downward. This is Fg, force of gravity. Fg equals mass times acceleration due to gravity. And then the body is sliding without any other force. And then there is a normal force. A normal force is always along y-axis. The normal force is a force that the surface exerts on the body. Then let us say that there is a friction. Because the body is moving downward, the positive direction of motion is downward. The friction force must be upward because the friction force opposes the direction of motion. Then the friction force is towards negative x. Now, where do we put the angle of inclination theta? The angle of inclination theta is an angle between the force of gravity and the negative y-axis. This means that this Fg is in x and y plane. So it has an x component, we use a broken line, then x component of the force of gravity is along x-axis downward. This is Fg along x, Fgx. And it has a y component. We need to find its projection along the y-axis. This one, it is looking towards negative y. This is Fg along the y. And now here it is said we need to apply Newton's second law. Apply Newton's second law. This means that the sum of forces acting on a body is equal to the mass times the acceleration. These forces are, we have the force of gravity, Fg, plus friction force, plus normal force, which is equal to mass times the acceleration. Now, we need to project forces along x-axis. The sum of forces along x-axis means the projection of forces along x-axis. Projection of forces along x-axis. Here, sum of forces along x-axis gives, we project the force of gravity along x, which is equal to Fgx. Then friction force is in negative x, it will be negative. Then plus normal force is along the y-axis. y-axis makes an angle of 90 degrees with x-axis times the cosine of 90 degrees. This is equal mass times the acceleration. This cosine is equal to 0. Then fgx, this projection of fg along x equals mg sine theta minus friction force equals mass times the acceleration. If friction force is equal to 0, then mg sine theta equals ma, and acceleration equals g sine theta, like this. Then if friction force is different from 0, then we know the friction force equals the coefficient of friction times the normal force. Then we need to find the normal force. To find the normal force, we find the sum of forces along the y-axis. Means Fg, try projecting, will be projected along the y-axis. It will be Fg, y, but it is oriented in negative x, in negative y. Then the friction force is along the x-axis. It will be a friction force times cosine 90 degrees, because the x-axis and y makes an angle of 90 degrees. Then plus normal force. This is equal to 0. Then we have Fgy equals minus mg cosine theta. Cosine because Fg makes an angle with y-axis. Minus because it is looking in negative y. Plus normal force equals 0. This is equal to 0 because there is no motion along y-axis. The motion is along x-axis. Then normal force equals mg cosine theta. Then if you replace, let us say equation 1 and this equation 2, put 2 into 1. We have friction force equals mu mg cosine theta. Then we have said if friction force is different from 0, then we have seen that here in this equation mg sine theta minus friction force equals mass times the acceleration. Means mg sine theta minus mu mg cosine theta equals mass times acceleration. Then acceleration will be equal to mg sine theta minus mu mg cosine theta over m. But the m will be simplified. This is how you will perform calculation.